Hey guys, these are our notes for our third day of solving quadratics by factoring, and what's new today is we're going to be using the distributive property sum as we are doing solving. But let's review what we did from last class. So last class we were doing variables on both sides. So we had a variable on the left and variable on the right. And when you've got variables on both sides, you need to pay attention to the term with the greatest exponent. So the x cubed has the greatest exponent. Its coefficient is a positive 1, and so when you've got your term with the greatest exponent and a positive coefficient, that tells you that you're going to move the terms from the other side towards that term that has the greatest exponent and a positive coefficient. So we need to move the 4x plus 48 over to the other side. So now that we've got the concept, I'm going to clear that off and let's do our process. So we need to subtract 4x from both sides, and we also need to subtract 48 from both sides. And then we have a new expression that we're going to be looking at, and I'm going to have the greatest exponent term go first, and then go in descending order, which means that the exponents go down. And that's a way that typically is going to make things easy for us to factor. This is an equation, so I've got to have an equal sign in it, and because everything on the right canceled out, I've got equals 0. Now I'm going to count up my terms. So I've got 1, 2, 3, 4 terms on the left-hand side, and that gives me a clue to do factoring by grouping. So looking at the first two terms, I'm going to take out what's common to those two. So I'm going to look at x cubed plus 12x squared. The thing that goes into both of those terms is x squared. So that's our expression that we're going to factor out. And we're going to have an x plus 12 left over. Now let's look at our second group. So our second group has a negative as its sign. So when I do my factoring, I'm going to take out a negative. And I'm going to think about what goes into negative 4 and negative 48. 4 is the greatest value that goes into both. So I'm going to take out a negative 4, and when I do that division, I get x plus 12 left over. This is an equation, so I'm still going to have equals 0. So I've gone from 4 terms to 2 terms. Now I'm going to look at my 2 terms, the purple term and the red term, and the part that is in common is the x plus 12. So that's my new GCF. For factoring by grouping, that's what we're doing right now. And now I'm going to write over my leftover factor. So I've done my factoring from my 4 terms on the side, and now I'm going to have to look at my answers, and I'm noticing that one of the parentheses is x squared minus 4. That's 2 terms, so I'm going to look for a pattern. And the pattern that I'm going to use for this one is a difference of squares. So x got squared to make x squared, 2 got squared to make 4. So with my difference of squares pattern, again what I'm doing is I'm factoring this expression x squared minus 4, and I'm going to get x plus 2 times x minus 2. The x plus 12 factor is going to remain, and because it's an equation, it's still going to equal 0. So now I've factored all the way, and I know that I'm done with my factoring because all of the exponents are a 1 on the variable, and so I'm ready to set my factors equal to 0 and solve. So I'm going to take the x plus 12, set it equal to 0, and solve. Take the x plus 2, set it equal to 0, and solve. Take the x minus 2, set it equal to 0, and solve. So I've got 3 solutions to this equation. So that's what we did last time. So today we're going to deal with what happens if your quadratic equation has parentheses. And our main idea is that we are going to distribute to get rid of parentheses. So that's the main thing that we're focusing on today. Distribute to get rid of parentheses. And then our steps are going to be like we did previously. So we'd move all terms to one side so that the leading coefficient is positive, and then we're going to factor, set each factor equal to 0, and solve. So let's try one out. So here I see parentheses, and on the left side, the value that's in front of the parentheses is a 2, and I need to distribute the 2 through the parentheses. so I get 2n squared minus 8. On the right-hand side, I see a 3 in front of the parentheses, so the way I get rid of the parentheses is I distribute through the parentheses. Now I'm going to set my equation equal to 0, and I need to pay attention to which term has the greatest exponent and make sure that its coefficient is a positive. So I'm looking over and I'm seeing the biggest exponent is a 2, and the coefficient of that term is a positive 2. So I need to move things from the right over to the left. So I'm going to subtract 3n, and I'm going to subtract 6. Okay, now let's write the left-hand side in descending order. So I've got 2n squared minus 3n minus 14, and this is an equation, so I have to have equals, and all of the terms on the right canceled out, so that is equal to 0 on the right. Now I'm going to count up my terms. I'm seeing 3 terms, so I've got 1, 2, 3 terms, which gives me a clue that I should try big X. So I'm going to multiply A and C together, and then I'm going to add to B. So A times C, I'm going to be thinking 2 times negative 14, and 2 times negative 14 is negative 28. B is a negative 3. Now let's think about our signs. So AC is negative, and that means that I need opposite signs. B is negative, so that means the larger of the two is negative. So let's think about some different ways to multiply to 28. So we've got 1 times 28, we've got 2 times 14, and 4 times 7. The larger of each pair is going to be negative, and now I'm going to be adding those values together. So 1 plus negative 28 is negative 27. That's not it. 2 plus negative 14, that's negative 12. That's not it. 4 plus negative 7 is negative 3. That's the one that I need. My A value is not equal to 1, so I cannot do a shortcut. I have to replace the BX term. So I've got 2n squared plus 4n minus 7n minus 14 equals 0. We'll do factoring by grouping because we've now got 4 terms. So what's common in my first group is a 2n. In my second group, the 7 is negative, so I'm going to take out a negative, and the value that goes into 7 and 14 is 7. So when I do my divisions, I get n plus 2. Again, this is an equation, so I need to have equals 0. So I've changed from 4 terms into 2 terms. What's common to the 2 terms is the parentheses, so I've got the n plus 2 in common, and then the other factor would be the 2n minus 7. Now that I've done my factoring, I'm going to set each factor equal to 0 and solve. So I'm going to take the n plus 2, set it equal to 0, and solve. I'm going to take the 2n minus 7, set it equal to 0, and solve. And what I'm thinking right here is I'm going to move over the 7 by adding 7 and then divide by 2. So I get n is equal to negative 2, or n is equal to 7 over 2. That circle wasn't beautiful. So that's our concept of what's going on. And the next few examples are going to be problems that are similar to this, worked out just like with maybe different iterations with signs and just some different kinds of ideas. But we've done the main idea for notes at this point. Okay, so I'm looking at my problem. I know this is a quadratic because I see a 2 as the greatest exponent. And as I'm looking across my problem, I see a 3 in front of the parentheses on the right. So, because I see parentheses in a quadratic, I need to distribute And then I'm going to set my problem equal to 0. Because x squared has a coefficient of a positive 1, that's implied, that's a positive 1, so I need to move everything from the right over to the left. So I'm going to subtract 3x, and I'm also going to subtract 27. So I've got x squared minus x minus 20 equals 0. On the left there are 3 terms, so that gives me a clue that I need to think big X. So I'm going to do a times c, and I'm going to add to b. A times c, I'm thinking 1 times negative 20, and my b term is a negative 1. So let's go through signs. So AC is negative, and that means opposite signs. B is negative, so that means the larger of the two that would multiply to 20 is going to be negative. So let's think about our ways to multiply to 20. So we've got 1 times 20, 2 times 10, 4 times 5, and the larger of each pair needs to be the negative. The combination that works for us is the 4 times negative 5. And a is equal to 1 on this one, so that means that we can do our shortcut. And that's where we just use our big X information and write down our 2 factors. Okay, so we've done the factoring. Now we're going to set each factor equal to 0 and solve. So our 2 solutions are x equals negative 4 and x equals 5. Okay, for our second example, our concept is going to be the same. There's a little bit more going on in this problem because we have a lot more terms to deal with. So I see 3 different sets of parentheses, so my first idea is going to be to distribute the coefficients of each of those parentheses through so that I don't have parentheses anymore. So I'm going to start off by taking the 6 and distributing through. Okay, so I've distributed through the 6. The plus 3m is still on the left side, plus 3m squared, so I'm going to make sure I write that down. Then I get to my equal sign. Now I'm going to distribute the 5m squared through the set of parentheses. And I'm just going to distribute to the set of parentheses that's directly after the 5m squared. So 5m squared times m is 5m cubed, and 5m squared times 1 is a positive 5m squared. The third time I see parentheses, I see a negative 3 coefficient, so I need to multiply the negative 3 through the parentheses. So I'm going to do negative 3 times m and negative 3 times 6. So I'm paying attention to my positive and negatives while I'm doing that. Okay, let me look through, and I'm going to look on each side to see if there are any like terms. So what I'd be looking for a like term on a side is I would be looking for the same variable to the same powers. When I look on the left side, I see an exponent of a 3, no exponent written down, no variable, and then a 2. So I know that on the left side there are no like terms. Now I'm going to look on the right side. I see an exponent of a 3, a 2, a plain old m, and a constant. So I don't see any like terms on the right side. And I just need to check that out because that helps to simplify my problem. The next thing I'm going to do is I'm going to look for the greatest agreed term. So that means I'm looking for the term that has the biggest exponent. So when I look at all these terms, I'm seeing an exponent of a 3 on the left and an exponent of a 3 on the right. So I'm going to look at their coefficients now. I see a 6 coefficient on the left of the 6m cubed, and on the right I see a 5 coefficient, so I see a 5m cubed. So that gives me a clue that I should move all the terms to the left. So I'm going to subtract 5m cubed. So I'm moving the smaller variable. That's how it links together with what we have done previously. And all the other terms need to move over also. So I'm going to subtract 5m squared, and I'm going to make sure I line up all of my matching powers. I'm going to do a plus 3m on both sides, and I'm going to do a plus 18. Okay, so on the right, all the terms cancel out because they're opposite, so I'm going to have an equals 0 on the right. And on the left, I'm going to write down each term that's remaining when I do either the addition or subtraction. So I'm thinking 6m cubed minus 5m cubed, and that is a 1m cubed. The next power that I would want to write down is the squared, so I'd be thinking m squared minus 5m squared. That's a negative 4m squared. Now I'm going to do the term that has the plain variable, so I'm going to be doing 12m plus 3m. Excuse me, negative 12m plus 3m. That's negative 9m. And lastly, I'm going to do the constant, so I'm going to be thinking 18 plus 18. That is a positive 36. So I've got 4 terms. 4 terms means grouping when I'm doing my factoring. So I'm going to look for some grouping. So let's look at the first 2 terms. What's in common between 1m cubed minus 4m squared is an m squared. So m squared can divide into each of those terms. So I'm thinking division like we've been doing for a long time with my factoring. In the second pair of terms, I'm noticing the third term is a negative, so I'm going to use a negative, and 9 is the value that goes into 9 and into 36. That's the greatest. When I divide negative 9m divided by negative 9, I get a positive m. 36 divided by negative 9 is a negative 4. Again, this is an equation, so I have to keep equals whatever it is, in this case it's 0, on the right-hand side. So I've gone from 4 terms to 2 terms. Now I'm going to look at the parentheses. Do you notice how they're the same? So that set of parentheses is my new GCF, and my leftover factor is m squared minus 9. Again, this is an equation, so it equals 0. Now I'm going to look at my sets of parentheses and see if I can factor some more. For the first set of parentheses, where I see the m minus 4, that exponent there on the m is a 1, so it's pretty much communicating, hey, we're done with factoring. On the second factor, I see m squared minus 9, and that m squared minus 9 is a difference of squares. Because m squared is a perfect square, 9 is a perfect square, and there's a minus in the middle. So now I can do my factoring for that portion. So I'm going to have an m plus 3 and an m minus 3 following the difference of squares pattern. So I've got m minus 4, m plus 3, and m minus 3 as my 3 factors. I'm going to set each of them equal to 0 and solve. And some of you guys may be noticing patterns with this last step where we write down what the factor is, set it equal to 0, and solve. And if you are to a place where you're starting to notice your patterns with these, you can start using that pattern. Algebra 2 will be absolutely fine with that. Okay, so we've got our 3 solutions. Okay, for our next example, again, I see parentheses, and right now it doesn't look like a quadratic to me, but because of the parentheses, that gives me a clue that I do need to distribute. So I'm going to start off by distributing the 5h through the parentheses. I'm going to write down the plus 34 again, just so that I'm making sure I'm keeping track of everything that was originally in the problem. And now I'm to my equal sign. So I'm looking at the right side now. So I see the 7, so I'm going to distribute the 7 through the set of parentheses. Now I'm noticing that we do have a quadratic. So I see that first term, 5h squared. It's the only time that I see a squared or any other power that's written out. So that gives me a clue that that's going to be the term, the 5h squared is the term that kind of dictates what I do from here. So the 5h squared has a positive coefficient, that's the 5, and the squared is the greatest exponent. So I should move everything from the left over to the right. So I should subtract 28 from each side, and I should add 7h to each side. Okay, so now I have a trinomial. And when I have a trinomial, when I have three terms, that gives me a clue that I should think about big X kinds of things. So I need to multiply A and C together. A is 5, C is 6. 5 times 6 is 30. B is 17, and I need to add to B. So let's think about our signs, our positive negatives. So AC is positive. That means same signs. B is positive, so that means both are positive. So that's going to help me out when I think about different ways to multiply to 30 and how to handle the adding up part. Okay, here are my different ways to multiply to 30. Again, I need same signs and both positive, so I don't need to write any negatives through this. And when I add up those values, the two values which add to 17 are 2 plus 15. So that's what I'm going to be using. And A is not equal to 1, so there's no shortcut. So I have to replace the BX. So I'm going to keep the 5h squared, and now I'm going to replace the 17h with plus 2h plus 15h. And then the 6 stays as it is, and keep this in equation with the equals 0. Now we're going to be looking for our factoring by grouping. So in our first group, h is in common. In our second pair, I see a positive 15, so I'm going to use a plus, and I'm going to think about what goes into 15 and into 6, and the greatest value that goes into both of them is a 3. So I'm thinking 15h divided by 3 and 6 divided by 3. Keep this in equation, so it's going to be equals 0 at the end. So I've gone from 4 terms now to 2 terms. And what's in common for the 2 terms is the parentheses 5h plus 2. So that's my new GCF. It's one of my factors. And the remaining factor is the h plus 3. Again, keep this in equation equal to 0. And now that we've done the factoring, we've gotten through the tricky part of the problem. And we're going to set each factor equal to 0 and solve. Okay, so what I'm doing for this one is I'm subtracting 2, then divide by 5. So I'm subtracting 2 and dividing by 5. So if you can do that all in one step, it's absolutely okay. So I've got 2 solutions here. For problem 4, I see squares, so I know that I'm going to be getting rid of parentheses and setting things equal to 0. And I want you to pay attention to the way the bases on these 2 squares look. So on the left, there's parentheses g plus 6, and then the squared, and on the right, there's a g squared. And the g plus 6 getting squared means that I've got 2 of those factors written in a row. If I want, I could distribute through. I'm going to wait. So I'm going to keep the 3 parentheses g plus 12 as it is. And just keep in mind that g squared, this last term here, that just means g times g. So I'm just going to leave that as a g squared. So on the left here, I'm going to have to FOIL. So this is where you could use double distributing, or you could use a box method to multiply these two binomials together. I'm going to do double distributing just because then everything's in line. So I have to do g times g and g times 6, and then I'm going to distribute the 6 through. So I'm doing my FOIL pattern, 6 times g, and now I'm doing 6 times 6. Okay, so I've gotten rid of the parentheses on the left. On the right, I need to distribute the 3 through the parentheses that follow it. And then the minus g squared needs to stay as it is. Okay, so now I need to figure out, do I move everything to the right or to the left? So I'm going to look at my two greatest exponent terms. I see g squared and negative g squared, and I need to move the smaller variable. So I'm going to add g squared to both sides, because negative 1g squared is a smaller coefficient than positive 1g squared. So I need to add g squared to both sides. That gives me the clue then that I need to subtract the 3g, and I also need to subtract the 36. Okay, let's see what we've got. So g squared plus g squared is 2g squared. The purple 6g is still hanging out, and then I'm going to be thinking 6g minus 3g, and then 36 minus 36 is 0. And then everything on the right, because we were adding opposites, that all adds up to 0. I see some like terms, so before I decide on how to do my factoring, I'm going to add my like terms together. The 2g squared didn't have like terms, but 3g and 6g are like terms. And with the plus 0 at the end here, I don't need to write that down because of the additive property of 0. Okay, I see two terms here, and I don't see difference of squares. So two terms, usually we'd look for a pattern, but this isn't a squares pattern. What this is instead is a greatest common factor. So when I look at these two terms, the 2g squared plus 9g, I see that g is in common, so I'm going to factor that out. So the GCF I took out had a letter with it, so I need to take that GCF and set it equal to 0. There's no solving to do, so that tells me that one of my solutions is g equals 0. The other factor was the 2g plus 9, set it equal to 0. So g is equal to negative 9 halves. So my two solutions are 0 and negative 9 halves. Okay, our last few problems are going to deal with what we do if there's a fraction. So if you see a fraction, you need to multiply each term by the least common denominator. And that's going to help us to get rid of any fractions. So for problem 5, I see some fractions. I see a 4/3 and a 5/3. So in this problem, my least common denominator is 3. Because 3 is the smallest number that the denominator 3 goes into for both of these fractions. So I'm going to multiply everything by 3. There are two ways that you can show this. I think I'm going to do parentheses on each side. So I'm multiplying each side by 3. So I'm going to do 3 times 3w squared and 3 times 4/3 w. So 3 times 3w squared is 9w squared, and 3 times 4/3 w is going to be 12/3 w. So remember, when we multiply by fractions, we are going to multiply tops together and bottoms together, and the coefficient that we were multiplying by That's a numerator, so that's why I multiplied the 4 by 3, and I did not multiply the denominator 4 by 3. On the right side, I've got 3 times 5/3. So I'm going to do 3 times 5, and then the denominator is getting multiplied by 1, because the denominator on the 3 is really a 1. Okay, let's look at our problem. Do you notice that each of those fractions that you see right now can just simplify to a value? So 12 divided by 3 is 4. 15 divided by 3 is 5. Now we've got kind of a regular problem. So we set this equal to 0. I did that by subtracting 5 from each side, and then we're going to have 3 terms, which is big X. So A times C, in this problem I'm thinking 9 times negative 5, and then B is 4. So I'm multiplying to negative 45 and adding to 4. So AC is negative, that means opposite signs. B is positive, and that means that the larger is positive in each of the multiply pairs. Okay, so let's think about ways to multiply 45. So I've got 1 times 45, I've got 3 times 15, and 5 times 9, and the larger is positive. That implies the smaller one is the negative. The combination that works in this situation is negative 5 and 9. A in this problem is 9. That's not equal to 1. So there's no shortcut. I've got to replace the bx. So let's do that. And now we'll do factoring by grouping, because now we have 4 terms, so we can do grouping. W is common in the first group, in the first pair. In the second pair, I'm seeing that it starts with a positive 9W, so I need a plus, and the expression that goes into 9W and into 5 is a 1. So when we do our factoring by grouping, we have to say that something divides in, and 1 could be the thing that divides in. Okay, so we've now gone from 4 terms to 2 terms, and our 2 factors then are going to be 9W minus 5 and W plus 1. Again, this is an equation, so I've got it equal to 0, and we'll finish off by setting each factor equal to 0 and solving. So we've got our 2 solutions. We've got 5 over 9 and negative 1 for our 2 solutions. Okay, we've got a couple more examples just to kind of help you guys out. So in problem 6, my denominators are 2 and 3. So my denominators are 2 and 3. Okay, so here's my 2 denominator and my 3 denominator. So I have to think about what's my least common denominator. So I'm going to think about the smallest number that can get divided by 2. So 6 can get divided by 2, and 6 can also get divided by 3. So my LCD in this problem is a 6. So what I need to do is I need to multiply both sides by 6. And you could think of the 6 as being 6 over 1. Okay, so 6 is the same as 6 over 1, if you want to think of it as a fraction to help with the multiplying. So let's multiply through. So 6 over 1 times 3 halves n squared is going to be 18 halves n squared. So I multiply the 6 by 3 and the 1 times the 2. Now I'm going to multiply and do my second term. So I'm going to do 6 over 1 times 2 over 3. So I'm thinking 6 times 2 for the numerator and 1 times 3 for the denominator. And I also need to multiply the right side by 6. So I'm going to have to do 6 times 2. That is 12n. And if you look at each of the fractions that's remaining from that multiplication that we did, do you notice that each of them becomes an integer? So 18 divided by 2, we know how much that is. That's 9. 12 divided by 3, we know what that is. That's 4. And now we've got a problem that's just like what we've done in the last few classes. So my greatest exponent is a 2. Its coefficient is a positive 9, so I need to move the 12n over. So in descending order, I've got 9n squared minus 12n plus 4 equals 0. I've got 3 terms, so I need to do big X. So my a times c, a is 9, c is 4, a times c is 36. 9 times 4 is 36. And I need to add to b. So my value for b is negative 12. So AC is positive, so that means I need same signs. B is negative, so that means both are negative. Okay, let's go think through our different ways to multiply to 36. So I've got 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Because I've got same signs, both negative, that means that each pair needs to be negative in this set. And the combination that works is the negative 6 times negative 6. Alright, A does not equal 1, so I can't do a shortcut. I have to replace the bx term. So let's see what we've got. There's the 9n squared. Now I'm going to replace the middle term and replace the bx terms and keep the last the same and keep it an equation. Okay, now let's do our factoring, because now we've got 4 terms. So the first pair of terms has a 3n in common, so I'm going to do my division. The third term is negative, so I'm going to take out a negative for sure, and the value that goes into 6 and into 4 is a 2. Okay, so the factor that's in common with the 2 terms that we've got now is the 3n minus 2, and then the leftovers are 3n and minus 2. So in this situation, we have 2 factors that are exactly the same, and that's okay. It just means that we have a double root. If we were looking at the graph of this, the vertex would be on the axis. And what we're going to be doing then is taking our factor, 3n minus 2, set it equal to 0, and solve. You don't need to show both of these factors equaling 0 and solving, because they're exactly the same. And what that means is our solution is a double root. And that just means we have the same solution twice. Okay, I think that's it. Thanks guys so much. Check out the stuff on Google Classroom for practice that we've got going on, and I hope you guys are well, and I'll talk to you soon.